Okay, so now what we've got here is a graph of a cubic function. So the first thing that we need to do is go through and try and figure out what information we can get off of this guy that could help. Well, one of the pieces of information that's really important are the x-intercepts. And this guy has 3 of them. And because it's got the 3 x-intercepts and the shape that this graph is, we know that this is going to be a cubic function. And we know cubic because it's got 3 x-intercepts. And so this would be the least degree possible that it could be. And we know that if one side's up and one side's down, it has to be odd. So we've got a cubic function, and we've got our 3 x-intercepts here. So what does a cubic function look like when you graph it out? Well, it's going to be something like y equals some coefficient a, which we don't know, and then we've got all the zeros. And so if you'll think back, one of the ways that we could write the point of -4 as zeros, we would just say this is x plus 4. And then one of the ways that we could write +1 as a 0 would be x minus 1. And then one of the ways that we could write +3 as a 0 would be x minus 3. And so this is great. The only problem is I've got 3 variables, and so I can't solve my problem out. That's easily solved. We just pick another point off the graph that we know the graph goes through, and I like points with as many zeros as possible. Well, let's use the point right here, 0, 6. And what that means is all the x's will be zeros, all the y's will be 6. And so I've kind of got a new function here, a new shape anyway. And so I just substitute in my numbers. 6 equals a times 0 plus 4, 0 minus 1, and 0 minus 3. And then I just solve this guy for a. And once I solve it out for a, I've got an equation. There's nothing else that I'm going to need to do. So 6 is equal to a times 4 times -1 times -3. And let's see. 4 times -1 is -4. Times -3 is going to be +12. And then you just solve that bad boy out for a. So a is going to be equal to 6 over 12, or 1/2. But remember that with this particular guy, oh my goodness, this needs to be a -6 right here. -6. So this is going to be -6. We just need to remember that when we do this, we've got a negative cubic. And the reason we know that is because on the left over here, this guy's pointed up, and on the right, this guy's pointed down. Well, that's if you have a leading coefficient that's negative. So what would my equation be then, given this information? And again, we would need to write the equation down like we would graph it on our calculator. And it would just simply be y equals -1/2, there's the negative part, times x plus 4, times x minus 1, times x minus 3. And that's all that you need to do on this guy. The other thing that you could do is if you've got your calculator, and you can look on my YouTube channel, but you could create a list of coordinates that are on this point or on this graph. So like -4, 0, 1, 0, 3, 0, and if you want to put this other one in just for good measure, 0, -6. You can go in and you can do regression analysis, and we would choose to look for a cubic regression, and that's all that you would do on that guy, and it would help. Your calculator would do some of that math for you. So it can be pretty easy, but also if you're not super fluid on your calculator yet, this could be a few extra steps, but definitely worth it in the long run. So anyway, that's how you find an equation for a polynomial from a graph. Okay, this is kind of fun. This is looking at triangular numbers, and we've got a formula for finding the nth triangular number. In other words, if I wanted, these are the first five, and you can see that because it tells us right here, the first triangular number has 1, the second triangular number has 3, the third triangular number has 6, the fourth triangular number has 10, the fifth triangular number has 15. So if I wanted to know like the eighth triangular number, if I wanted to know the eighth triangular number, then I would let n equal 8. And I would just put it into this formula. So what I'm going to have is a function where n is going to be 8, and it would be 1/2 times 8 squared plus 8. So whatever that came out to be. So, 1/2 times 64 plus 8, which is 72. So half of 72 would be 36. So if I did my math right there, the eighth triangular number would be 36. Well, what we want to do here is show that this function has constant second order differences. In other words, if you'll notice off of this guy, the difference from here to here, okay, the difference from here to here is 2. From 1 to 3, the difference is 2. The difference from 3 to 6 is 3. The difference from 6 to 10 is 4. And the difference from 10 to 15 is 5. That's the first order of differences right here. This is the first order. It's the first grouping. Okay? And so the question says, show that this function has constant second order differences. So what we'd want to do is we would want to show that all those second order numbers are all the same. So in order to do that, we would just slide down again. The difference between 2 and 3 is 1. And the difference between 3 and 4 is 1. And the difference between 4 and 5 is 1. And these guys down here are your second order differences. And all of those differences are the same. And if everything is the same, it's constant. So the first order difference, there's 1 unit of difference between all of those. The second order difference is constant because they are all 1. That's all there is to it. Don't let this be difficult. Just make these, look at what the differences are between those y coordinates, and you'll see once you start comparing them that there really is a cool pattern that starts to take shape. Okay, the first 7 triangular pyramidal numbers are shown below. Find a polynomial function that gives the nth triangular pyramidal number. We're going to need our calculators, so have that thing close by. But let's just look at a few things here. F of 1, in other words, the very first triangular pyramidal number, is equal to 1. And f of 2, in other words, our second triangular pyramidal number, is equal to 4. F of 3, our third number, is equal to 10. And you can count these dots if you want. The fourth triangular pyramidal number is equal to 20. The fifth triangular pyramidal number is equal to 35. So we go from, and let's just look at these differences just real quick as well. So from 1 to 4, my first order of difference is 3. From 4 to 10, my order of difference is 6. From 10 to 20, my order of difference is 10. And from 20 to 35, my order of difference is 15. Okay? We can look in our book, and if you look in your book, you'll see there's a few more that I wasn't able to get written down here, but they gave us the f of 6. The sixth number is 56. So that order of difference then goes from 15 to, let's see, 35 to 56 is 21. And then they also gave us the 7th one. I don't quite have room for it. But the 7th one is 84. And so if we look at that first order of difference, going from 56 to 84, that would be 28. So I'll just write 28 over here on the edge so we've got it to look at. And then now let's go with our second order differences. So this would be 3, 4, 5, 6, and 7. And then let's look at our fourth order of difference. And looky here, they're all going to be 1. So there's my constant term. Okay? So it takes me all the way down to the fourth order of difference. And so what we're going to do then is we're going to create a system that has 4 equations and 4 unknowns. And this is going to be a really interesting thing to do because we'll end up using our calculators and creating a matrix. So I'm just going to expand this page a little bit here. And what we're going to do is we're going to look at these orders of difference, and we're going to create an equation. And we're going to want something that looks kind of like this. This is the thing that we're going for here. We need 4 variables, okay? And so we're going to go for, let's see, we're going to go for something like this. Y equals ax cubed plus bx squared plus cx plus d. This is the shape that we're going to go for on this guy. Now the reason we're going to go for a cubic equation on this, the y equals ax cubed part, is because we had to go to the third order of difference. So if you're going to a second order of difference, you would square it. A third order of difference would be a cubic. A fourth order of difference would be a 4th degree equation. So we know that since we're going to a third order, that we're going to have a cubic equation. And then we're just going to fill in our information right here on this guy and create a matrix based off the numbers that we have from the from writing out what all the orders of difference are. So we would start with that third bunch, and it would look something like, well, actually it might be easier to do this. Check this out. If I go, I'm going to have a times 1 cubed, and then I'm going to have a times 2 cubed. And then I'm going to have a times 3 cubed. And then I'm going to have a times 4 cubed. Okay. And the reason that I'm doing that is because I've got to be able to solve for all of these variables, A, B, C, and D, so I need 4 equations with 4 unknowns. And I'm just solving for my 1, my 2, my when x is 3, when x is 4. So that's what I'm looking at. And when I do that, I'm just going to put in for x, all x's here will be 1s. And then I'm going to let it equal what that very first guy equals, which is just going to be 1. And so notice that I'm looking at my second number, my third number, my fourth number. So when n is 2, when n is 3, when n is 4. So let's see, this would be squared. So this would be b times 2 squared plus c times 2 plus d. And my second pyramidal, triangular pyramidal number is 4. And then now my third pyramidal triangular number. Whoops, that should be a C. That's ugly. my third pyramidal triangular number, 10. And then my fourth pyramidal triangular number. And my fourth pyramidal triangular number, 20. And then what you're going to do is you're going to plug all these in. We've got a matrix. And you're going to plug all these into your matrix, and you're going to use the RREF feature of your calculator. And if you don't remember how to do that, look it up on my YouTube channel. But we're going to go for an RREF matrix form of an answer. And this is going to be really nice because it's going to give us the exact answer that we want, exactly how we want to see it. But you've got to put in the right numbers into your matrix. So this matrix is going to be 4 rows by 5 columns. Okay, it's going to be a 4 by 5. And you're just going to put in the coefficients. So I'm going to have 1, 8, 27, and 64. Those are just the coefficients. That's 1 cubed, 2 cubed, 3 cubed, 4 cubed. Then I'm going to square the 1, square the 2, square the 3, square the 4. And then I'm going to have my 1, 2, 3, 4. And then the coefficient on that D, how many D's are there? Just 1. And then finally my Y coordinates, 1, 4, 10, and 20. Okay, put this into your calculator, and what we should get back is a cubic equation. We should know exactly what A, B, C, and D are. And remember, this is your A column, your B column, your C column, and your D column. So take a minute right now, plug these into your calculator, and see if you get what I get. Okay, so I used my Inspire again. It's a little bit easier to see the final answer. And when you use the matrix formula, you get right here, this is going to be your A. Don't forget, this is your A column, your B column, your C column, your D column. And so 1A is equal to 1/6. And 1B is equal to 1/2. And 1C is equal to 1/3. And notice in that last one it says 1 equals 0. That means that 1D equals 0. So when I put this together into a formula to figure out exactly what the pattern is for these groupings of pyramidal numbers, okay, then what I'm going to end up with is, remember, these are n's, not x's anymore. So I'm going to end up with 1/6 n cubed plus 1/2 n squared plus 1/3 n. Okay, and this is going to be our function of n. Well, what is this? This is right here. This is these are the ways that you find the triangular pyramidal numbers. And so if we wanted to know what the 15th triangular pyramidal number was, instead of having an n, we would have a 15. If we wanted to know the 8th, instead of counting them out each time, we could just put an 8 in. So it's really just a pattern of numbers. And it's really interesting how all these things work out. But remember, it all comes down to being able to find your first order, second order, and third order differences so that you know what size of equation that you're going for. Because whatever the order is, that's the degree that you're going to be needing.